Hey everyone, I'm Aman and welcome back to the channel. Today we are starting something I'm really excited about, that is a Python FastAPI series where we are not just talking about building APIs but building them the way they should actually run in production. Here we will cover things like security, performance, reliability, and most importantly, the thing that we are going to tackle today is rate limiting. By the end of this video, you'll understand not just what rate limiting is, but why it's critical for production APIs and how to implement it in FastAPI using just a few lines of code. So stick around it, and if you find this video valuable, please hit like, subscribe to the channel so that you don't miss the upcoming videos in this series, and share this with someone learning FastAPI so that it really helps me out and helps others in the community. So let's quickly jump in. So before understanding rate limiting, let's first talk about what FastAPI is. So FastAPI is a Python-based web framework specifically designed to build APIs. And yes, the name literally says it's fast. Here, we write very little code and it handles requests quickly, and it's designed to scale as your user base grows. That's why a lot of team uses FastAPI when they want something very simple, but again, production ready, then they opt for this FastAPI. Now, with that, let's talk about why rate limiting matters so much in an API that is built using FastAPI framework. Imagine you own a small coffee shop. One day, a customer walks in and starts shouting orders non-stop. Coffee, 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 over and over again. Now here's the problem. The person at the counter is completely overwhelmed. Person can't hear anyone else. All the other consumers standing in line, they are blocked. They can't get served even though they did nothing wrong. This is exactly what happens with your API too when you don't have the rate limiting implemented. One user or maybe a bot can send requests to so fast that it drowns out everyone else. Your servers get overwhelmed and genuine users can't use your app, and suddenly your entire service is down. That's what rate limiting prevents. So rate limiting is simply a concept. It's a rule that says each person can send only a certain number of requests in a given time period, and if someone crosses that limit, your API doesn't crash, but it politely says, hey, slow down, please try again in a moment. And that's it. That one rule keeps your API fair, stable, and usable for everyone. So now you might be wondering, if rate limiting is so important for production, why doesn't FastAPI just include it by default? And that's actually a good thing, because FastAPI focuses on being fast and more importantly flexible. Rate limiting depends on how your app runs and where it's deployed and what kind of traffic you expect. Maybe let's say like the traffic may be mostly consistent, or you may see some sudden spikes as well, because some teams implement this rate limiting at an API gateway end, some does it at a load balancer, and some does it within the app itself. So since there is no single correct way to implement the rate limiting, FastAPI lets you choose the solution that fits best for you and specific to the setup that you are currently working on. And that's where the libraries like SlowAPI comes into the picture. So SlowAPI is a small but powerful library built specifically to work with FastAPI and Starlit based web servers, and it lets you add rate limiting with just a few lines of code. You can say something like this, that allow only 5 requests per minute, and SlowAPI handles everything else. And it's not just basics, it also supports retry after headers, so client know when to try again later. It also include multiple strategies as well, which we will be talking in a moment. It also has an integration with Redis for distributed rate limiting when you scale across multiple servers. So these are all the features that SlowAPI provides. So with that, let's look at the actual code and walk through it step by step. So first we import FastAPI and a few helper class like request and response. This helps us read incoming request and send responses back to the client. Then we import limiter from SlowAPI. This is the main object that actually enforces rate limiting. Then we also import get remote address. This simply means that we are identifying users by their IP address, and this is just one option that we have implemented over here. In real SaaS applications, you usually don't rely on IP address. Instead, you can create your own functions that reads an API key from the request. That way, you can give free users lower limit and paid users higher limit. And also there are several other ways we can implement this rate limiting, by geolocations, by IP based, and by devices based using MAC address of the device. So SlowAPI makes it very easy to plug in this kind of logic. Next, we create this limiter itself, and then we tell it to use the client IP address as the key, then stores the counter in the memory, use a fixed time window strategy. So fixed window means requests are counted in clear time blocks, like 5 requests per minute. Then again, that window will get reset after completion of that entire minute. SlowAPI also supports sliding window, which is bit smoother. It looks recent queries instead of like resetting all at once. And it also supports moving window as well, which is even more accurate. It continuously checks how many requests happened in the last window and compare with the current window. But for this video, fixed window is simple and easy to understand. So I'll just kept this fixed window over here. And finally, we enable headers so the client knows when to retry. Using memory storage over here is fine for this demo and local testing, but in the real production applications, we can plug in Redis caching as well, for the distributed caching and storing the timestamp. And after that, we create the FastAPI app and attach the limiter to it. This step is important because it allows SlowAPI to hook into our entire app lifecycle. Now let's look at the exception handler. Again, this is the optional thing. Whenever someone crosses the rate limit, SlowAPI raises a rate limit exceeded error, and this method gets executed by default, uh, just to decorate the response that we pass into the client. Here we catch the error and return a clean response instead of just crashing the app or sending the generic response. We send back a 429 status code, which means too many requests, and then we also inject rate limit header into the response. These headers tell the client how many requests are allowed, how many are left, and how long they need to wait before trying again. And finally, we have this actual API endpoint with the limiter.limit decorator. Here we just specify that 5 requests are allowed per minute. It means each user can only call this endpoint 5 times per minute. If they go over that limit, then they will get blocked until the window gets reset again. And now we will just test this endpoint. So here I'm just executing this 20 times, and you can see that the first 5 requests got successful with 200 status, and then rest of the 15 calls we got this error of rate limit exceeded, and the status over here is 4 to 9. So this is how the rate limiting works at an endpoint level. And that's it. With just a few lines of code, we have added real rate limiting to our FastAPI application. This small change can save you a lot from production issues later on. And in the next video in this series, we are going to keep building on this foundation. We will cover authentication, caching, database optimization, and everything else you need to build FastAPI applications that are truly production ready. And if this video helped you understand rate limiting, I would really appreciate it if you hit the like button and subscribe for more content like this. It helps the channel grow and keep me motivated to create these deep dive tutorials. So thank you so much for watching. I'll see you in the next one.